Physical force is always a mutual exchange. When two massive objects collide in space, both experience the impact simultaneously. The formal definition states, every action has an equal and opposite reaction, or in Hindi, प्रत्येक क्रिया के बराबर एवं विपरीत प्रतिक्रिया होती है. Three conditions define this interaction. Forces exist in pairs, possess identical magnitudes, and act in perfectly opposite directions. In formal vector notation, when body A exerts a mechanical force onto body B, we label the interaction F sub AB. At that exact instant, body B exerts a force of equal strength but reversed trajectory back onto body A, negative F sub BA. Pushes and pulls are mutual exchanges between two distinct masses. This symmetry introduces a conceptual hurdle. If every force is balanced by an equal and opposite counterforce, physical acceleration appears impossible. Adding a positive force to an equal negative force results in a net sum of zero. A global view of these forces suggests they cancel out, which seemingly prevents any translation through space. Students often struggle with kinematics when they view the entire universe as a single, balanced system. Resolving this requires a shift in perspective. We must isolate systems to understand how motion occurs. Newton's third law is actually the fundamental mechanism that drives macroscopic motion, provided we define our system boundaries correctly. Consider a person standing on solid ground, pressing both hands against a concrete wall. The action phase begins when you apply 50 newtons of force directly into the concrete. Following the third law, the wall returns 50 newtons of force into your hands. The magnitudes are identical, and the directions are perfectly opposite. Why do these vectors fail to cancel each other to zero? Vector cancellation only occurs when multiple forces act on the exact same object. A free body diagram allows us to mentally separate one object from its environment to analyze the forces acting upon it. We draw a boundary around the person and ignore the wall. The 50 Newton action force you applied is targeting the wall, which is now outside our system. Only one active force enters this isolated boundary, the 50 Newton reaction from the wall pressing against your hands. Action and reaction pairs act on strictly different bodies. By isolating the individual, we see a defined net force that remains uncancelled. Moving from a static wall to a dynamic interaction proves how this net force creates acceleration. We begin with target block B with a mass of 10 kilograms. Object A initiates the interaction, driving 100 newtons of force into block B. Block B pushes back with an equal 100 newton reaction force. We isolate block B to analyze its motion. Newton's second law requires us to input only the forces acting directly on body B. We divide the 100 Newton incoming force by the 10 kilogram mass, resulting in an acceleration of 10 meters per second squared. The 100 Newton force exerted by body B is irrelevant to its own acceleration. Body B moves because the force targeting it is unopposed within its own system. This principle of system isolation allows for the engineering of extreme propulsion. A rocket works through the same isolated interaction. The engine forces expanding gas downward. In return, the mass of that gas pushes the rocket upward with 2,000 newtons of thrust. Because the reacting gas is expelled away, the rocket's frame receives the full 2,000 Newton upward force without any internal cancellation. We see the same mechanic in artillery fire. The explosion drives the cannonball forward, while the cannonball simultaneously drives the heavy iron carriage backward. Thrust and recoil are manifestations of the same force pairs acting on different masses. This interaction symmetry dictates all biological movement. Walking relies on pushing the asphalt backward with your feet. The earth absorbs this backward push and returns a forward force into your shoes, which propels your body across the street. Swimming follows the same requirement. A swimmer grabs and displaces water backward to exploit the reaction force that pushes them toward the finish line. Self-directed motion requires finding a second mass to push against. The ultimate rule of the universe is a simple exchange. Push, and you will get a push back. When analyzing the motion of a single object, remember to only count the forces targeting that object. F sub AB equals negative F sub BA, but those forces act on strictly different bodies. Newton's third law provides the mechanism